Show that this is convergent, and we have to check this. Is this decreasing and is this approaching 0? This is clearly approaching 0. Right? We have nothing on the top, a constant of 1, and n and 5 to the power of n, so it's going to quickly approach 0. So this second condition is satisfied. For the first condition, okay, I think it's best to consider the function version, which is x 5 to the power of x all to the power of -1. If you differentiate this, chain by okay, so that goes on top. Minus this goes on the bottom. Okay, so that can be reduced. So we have a minus 1 plus x ln of 5. X squared is always positive. 5 to the power of x is also always positive. So this thing will be decreasing when this here is positive, right? 1 plus x. Ln of 5 is a constant. Okay, ln of 5. When is this positive? Well, this is a line with y-intercept of 1, a slope of ln of 5, and just constantly going up. It's always positive, right? For all values of for x, right? Which means it proves that Tn plus 1 will be less than Tn, therefore it's converging. Okay, now we have to the second part. How many terms do we need so that we get our accuracy to be smaller than 0.0005? Now we use this here. We considered bn plus 1. So bn plus 1 is, right, 1 over n plus 1, 5 to the power of n plus 1. Okay, so we want this to be less than 0.00005. Which means n plus 1, the reciprocal of this, 5 to the power of n plus 1, needs to be greater than, right, greater than the reciprocal of that. Okay, which is 20,000. Okay, so this here is 5 to the power of n times by 5. Divide both sides by 5, and you have n plus 1, 5 to the power of n. And you get exactly 4,000. Okay, so the first value of n that goes over 4,000 is 5. In other words, we need 5 or more terms. Okay, 5 or more terms to get it up to this accuracy.